This is part one. What you actually see when watching a rocket launch. We start with the key question: what you actually see when watching a rocket launch. That brilliant streak climbing through the sky looks deceptively simple. But when you're watching a rocket launch, you're witnessing one of the most complex displays of physics in action. This is the first episode in our series breaking down what you actually see during a launch. Today's question: what exactly creates that dramatic visual spectacle that's visible from dozens of kilometers away? The answer lies in understanding three key elements working together. The exhaust plume. First, that brilliant flame isn't actually fire in the traditional sense. What you're seeing is superheated exhaust gases expanding rapidly as they exit the engine nozzles at temperatures exceeding 3,000 degrees Celsius. These gases are moving at roughly 3 to 4 kilometers per second, faster than most rifle bullets. The bright orange and yellow colors come from unburned fuel particles and metal oxides in the exhaust. As the rocket climbs higher and the atmosphere thins, this plume expands dramatically. What starts as a relatively narrow cone at sea level can spread into a massive, translucent cloud at altitude. Atmospheric interactions. Here's where it gets interesting. The atmosphere doesn't just provide resistance, it actively shapes what you see. At lower altitudes, air pressure confines the exhaust into that familiar flame shape. But as the rocket climbs and air pressure drops, the exhaust spreads outward, creating those ethereal, jellyfish-like formations. Weather plays a crucial role too. Humidity affects visibility and can create those stunning shock diamonds, the regular diamond patterns you sometimes see in the exhaust. Cold, dry air provides the clearest views, whilst moisture can scatter light and create rainbow effects around the plume. The light show. The most spectacular launches happen during twilight conditions, when the sun has set at ground level but still illuminates the upper atmosphere. The exhaust plume acts like a massive spotlight, scattering sunlight across hundreds of square kilometers. This creates those otherworldly glowing clouds that can be mistaken for everything from UFOs to atmospheric phenomena. Those color changes you see aren't random. As the rocket burns through different fuel mixtures and climbs through varying atmospheric conditions, the exhaust composition changes. The shift from bright yellow-orange to pale blue or white tells you the rocket is transitioning from dense atmosphere to the vacuum of space. Distance and perspective. Your viewing distance completely transforms the experience. From 5 kilometers away, you'll see individual engine bells and hear the crackling roar. From 50 kilometers, it becomes a silent, graceful arc of light. The physics remain the same, but atmospheric scattering and the limits of human vision create entirely different visual experiences. What makes this particularly remarkable is the scale involved. That small streak of light represents millions of pounds of thrust, temperatures that would vaporize most materials instantly, and forces that would crush a human being. Yet from our safe viewing distance, it appears as an almost gentle climb towards space. What this means. Understanding these mechanics changes how you watch launches. Those seemingly random color shifts, the gradual expansion of the plume, the way morning launches look different from evening ones. It all follows predictable physical laws. You're not just watching a rocket, you're observing thermodynamics, fluid mechanics, and atmospheric physics playing out on a massive scale. The next time you see that brilliant streak climbing skyward, you'll know you're watching superheated gases expanding through a changing atmosphere, creating one of the most visible demonstrations of human engineering, pushing against the fundamental forces of nature. Next episode, Part 2, explores the next key question: why rockets sometimes seem to disappear completely, only to reappear minutes later. If you found this breakdown useful, Subscribe for more plain English explanations of the physics behind space exploration. That is part 1 of what you actually see when watching a rocket launch. In part 2, we explore the next key question. Subscribe so you do not miss it.